In this video, we're talking about slant asymptotes. Not all functions have it, but certain rational functions could have a slant asymptote. It's also called an oblique asymptote, just in case you hear that. But basically what it is, it's an imaginary line. You can see in the picture, it's an imaginary line. Of course, it is a slanted line, and it tells us what happens with the function as x is getting really, really small. So as x is approaching negative infinity, and also what happens as x is approaching a positive infinity. It's basically telling us the end behavior of this rational function. So if a function has a slant asymptote, the asymptote is always in the form of y equals mx plus b, which is your basic equation of a line. And similar to the horizontal asymptote, a function can cross a slant asymptote, but mainly it tells us what happens as x is getting closer to infinity or negative infinity. So it really tells us the end behavior. So in this example, I've given you f of x equals x squared minus 3x minus 4 divided by x minus 2. This is an example of a slant asymptote. And the way you can look at a function and tell if there even exists one is you look at the leading terms of the numerator and the denominator. If you look at that, that would be x squared over x. The degree tells you everything. So we have degree 2 over degree 1. A slant asymptote exists when the degree in the numerator is 1 more than the degree in the denominator. So this exists because we have 2 over 1. It wouldn't work if we had cubed over to the first power. But as long as they differ by 1, we're good. Okay, and I've given you the slant asymptote. It happens to be y equals x minus 1. Remember, a slant asymptote is always in the form of y equals mx plus b, and this is the case. So let's look first. What happens as x approaches negative infinity? If we look at the graph, the picture of the graph, as x is getting really, really small, you can trace your function, and the function down here is approaching our slant asymptote. So we can say that y is approaching our slant asymptote, which is x minus 1. That's the actual equation of the line. But in reality, we would say that y is approaching negative infinity. You can look at it and tell because the equation of the graph is going down forever. So it's approaching negative infinity. And then if we look and say what happens as x approaches positive infinity, so as x is getting really, really large, same thing, the function is approaching the slant asymptote. Right, so we would say y is still approaching the same line. And that would be the same as saying it's approaching in positive infinity because it's getting big forever.